Welcome to Crank Software Inside the GUI. I'm Scott Snyder, Product Marketing Manager and Partner Enablement Manager at Crank Software. During this segment, we'll be focusing on one of our technology partners, Toradex. And today I'm speaking with Jeremias Cordoba. Hi, Jeremias.
Hey, Scott. Nice to be here.
Yeah. Great to have you as well. Today we're going to be talking about the ins and outs of containerization, in particular with Toradex Torizon's platform. So before we begin, can you please let everybody know a little bit about yourself and your role within Toradex?
So as Scott was saying, I'm Jeremias. I'm kind of a multifaceted tool here at Toradex. I mostly do kind of sales support work as an FAE here at Toradex. Specifically focusing on our Torizon platform and helping our customers kind of get online with that platform.
So Toradex offers embedded developers Torizon, which is an open source software platform using Linux software. But why should embedded developers look to use containers when it comes to their embedded Linux system?
So I guess I should start with the comparison here between kind of what Torizon is and what a usual embedded Linux system is. So, for most developers, as they may know, kind of the commonplace with embedded Linux is the need to build their own image or distribution kind of from the ground up using some kind of build system, the popular one being the Yocto build system. And those who have worked with the Yocto build system, even those that are familiar with it, may already know that it has quite a steep learning curve. So this kind of has a high entry to barrier for people coming into embedded Linux, even if they are Linux familiar themselves. So we kind of here at Toradex hope to tackle that with Torizon. So kind of the difference here with Torizon and a typical embedded Linux system is that while both are built with Yocto, what we do different here on Torizon is we plan to kind of distribute applications on the system in the form of images. So now I guess to the question now, why containers embedded Linux? Some embedded developers might not even know what containers are. So containers are kind of more popular in the kind of DevOps and microservices space. But basically, they're a very, very light virtual machine that has all of its software packaged independently from the base OS, and this can be distributed on different devices. So as you can see here on the screen right now, this is kind of the simplified version of the Torizon architecture. You see here the part above the hardware layer, we have kind of the base OS layer, what we call Torizon Core. So here we just have a Linux kernel, we have some services for an OTA client that's also available, and then we have the container runtime engine. In our case, we use Docker. And then on top of that is where we want customers to put their application in these little containerized bundles. So you can see here, each containerized bundle has its own libraries, binaries, separate from one another and separate from the base OS. This allows kind of more fine-grained control over each application, since you can kind of control what comes with it, separate from everything else. And this helps because you kind of have maintainability and updatability of each application without having to update the base OS. There's also more of a focus on just developing your application instead of the traditional method where you would have to kind of worry about your OS components and worry about, oh, I need this library on the OS, where can I get this library? Also with containers and specifically the Docker engine, we kind of leverage the already existing container ecosystem provided by Docker. So that way you don't kind of have to start your software from scratch. You can, for example, if you want a Debian environment to start off with, you can grab a Debian container off Docker Hub and so forth. And then also kind of a minor note, there's also kind of the security benefits of containers. Since they're isolated from everything else, you can kind of control what has access to the container or what the container has access to. Yeah.
Okay. So when it comes down to it, then how easy is it to package a cross-compiled application and all its dependencies into a container image?
Yeah. So I guess in this sense, it's not actually too different from how it would be without a container. So I guess to draw another comparison, so without a container, at least for our platforms, you would need some kind of tool chain that's compatible with your end target device. And then you would use that to cross compile whatever code base and then deploy that to the device. With containers, it's fairly similar. You would start with a container. You would put a tool chain in that container, the same tool chain, and then use that to cross compile. The nice part here is on both Windows and Linux, you can run Linux containers for the ARM architecture, either through some kind of emulation or such. That way you can just run these ARM containers natively on your host machine and then use either a toolchain or just natively compile it. Well, native in a sense.
Fair enough. What about when it comes to managing the licensing aspects of the content, such as the base OS, container images, and the likes?
Yeah, so kind of glad you asked this question. It's interesting. So there's kind of two parts here. As you said, you have to manage both the base OS and then the container images since they are separate pieces of software. So with the base OS, as I mentioned earlier, Torizon is built using the Octo project. So that inherently already kind of manages the reproducibility of the heart of the software and the licensing of all the software that goes into that. So that's already kind of handled as is. So the interesting part of this question is the second part, the container images. So this is kind of one aspect of containers where, at least today, there's not really a simple solution in terms of licensing. So kind of one of the main requirements of licensing is that you would need a reproducible build in terms of software, be able to guarantee that whenever you build the software, it's going to have the same versions of the same libraries and such. With containers, that's not always possible. So with the way containers work, it's kind of a layered system where each layer, you either grab some software from something or you add your own software. With that being said, you might not have control over every layer of software that goes into your container. So what might happen is you're basing your container off somebody else's container, but then that person updates their container at some point. And then when you do a rebuild of your container somewhere down the line, since it's using a different base, it's not the exact same image anymore. Of course, there are ways around this. You could try to mitigate it. It would basically come down to you need to have control over as many or all layers as you can. You might need to do some tricks such as freezing package feeds or grabbing snapshot of package feeds so you get the same versions every time. But yeah, this is something here at Toradex we kind of are planning to tackle in the future, see if there's something we can kind of do to better help with the licensing there.
That sounds great. That'd be really helpful. I know to a lot of developers looking to really kind of you leverage the containerization in their embedded projects. So with that being said, is there any tips or suggestions that you can provide developers when it comes to reducing their development time so that way they can get to market quicker?
Yeah, of course. So I guess, what are the two main parts here when it comes to embedded development? You have the hardware and you have the software. And I guess the best way to get kind of a head start on both parts is to, well, not start from scratch. You need to start from some kind of already pre-made solution. So for example, with Toradex, we provide these pre-made system on modules that already do kind of the main hard part of the hardware design. We already integrate the SoC, all the high speed signals, and make sure that's working for the customer. And then on the hardware side, as a customer, you would basically just have to do a carrier board and any peripherals or extra hardware you need. And then on the software side, it'd be helpful to start off with some kind of base framework or reference solution. So also here at Toradex, besides our Torizon software, we also provide embedded Linux BSPs as reference. So customers can start with these reference images so they have a solid base to work off of and then progress from there. And then, of course, this goes with any part of the design. If you could leverage something to start from there instead of starting from scratch. Example, if you need some kind of GUI, maybe start with something like Crank instead of, trying to write some kind of GUI application from scratch, especially if you don't have the expertise.
No, perfect. Yeah. And so just before we wrap things up for the day, what can embedded developers expect from Toradex in 2021?
Yeah. Yeah. So, I mean, as you probably already know, Scott, last year was quite a hectic year for most people. But this year, we kind of hoped here at Toradex to get back on track with our developments. So, kind of what you can look forward from us is, for example, as we've been talking about our Torizon platform, we just released our kind of first production quality quarterly release of Torizon at the start of this year in January. And we hope to continue that with quarterly releases throughout the year as we continue to expand the feature base and tooling around the Torizon platform itself. For example, we have these IDE extensions for Visual Studio and Visual Studio Code that people can use to develop applications. We hope to kind of expand on those and make them more featureful. And also on the Torizon platform, we are kind of working on a release for the OTA service that I mentioned earlier. That's part of Torizon. So Torizon itself has a client that can do over-the-air updates, but we hope to also provide on top of that a software service that can better manage these, so you're not just kind of doing them on the fly. So that's probably something else for people to keep an eye out for. And then on the hardware side, we're continuing to mature and flesh out our various hardware platforms, specifically surrounding the i.MX8 family from NXP, particularly on our latest form factor family, the Verdant family. Right now, we only have one system on module for the Verdant family, but we hope to come out with a second one based on the NXP's i.MX8M Plus SoC, which will be kind of more tailored towards machine learning type task, industrial IoT, a little bit more kind of heavier stuff.
Sounds like a lot of awesome stuff coming out in 2021 to look forward to. Thank you very much. And thank you very much, Jeremias, for joining us today. And thank you, everyone, for taking time out of your day to come join us for another session of Inside the GUI.